I'm Max, and this is an overview of my final project for computer vision. We were challenged to extend what we learned from PS3 and create a more robust augmented reality system that didn't need any special markers, that could automatically place the object into the scene, and also handle the object going out of view. After doing a bit of research, I decided to implement a system that used feature tracking of natural features within scenes. Here's an overview of the process. I'll come back to this, but first I wanted to talk about this step, of identifying a clear space to place an ad, which is somewhat of a separate procedure in and of itself. Given the input frame, a Gaussian blur is applied and an edge image is created using canny edge detection. Then the algorithm starts looking at a rectangular region from a preset starting point and uniformly expands that region until it detects an edge in its perimeter. It will then wiggle the proposed center point and try to expand further until a set number of times. And in the end, the rectangle with the largest area is chosen. There are obvious deficiencies to this approach. It assumes the clear space is directly in front of the user and is directly parallel to the camera. And of course, it's also brute force, and it seems to have done decently in most of my trials. Here's an example. The original frame is of my refrigerator door. On the right is an edge image. Now let's see a visualization of the process. Note that these videos don't represent the runtime of the algorithm, these are just for illustration purposes. And another example with an outdoor scene. Now back to the rest of the process. Now that we have a target for our ad, we create an initial homography to map the ad into the first frame. After that, good features are identified using the orb feature detector. With two sets of those features, we compute and update homographies using Ransack, which reduces bad feature matches, making for better homographies. We then apply this updated homography to place the ad into the scene. From there on, we use a Kanata, Lucas, and Tomasi tracker to try to efficiently track the features from frame to frame. After which, if the tracker can still track a good amount of features, we use those features to compute a homography as we did before. We continue to use the KLT tracker until we start losing feature matches, which can happen when the features go off screen, in which case we recompute a new set of good features to track and switch back to using KLT, and so on. Here are some examples of results from my implementation. Thanks for watching, and check out more details in my report.